Hi, a very good morning to Dr. Daniel, our lecturer for this subject, Electronic Engineering Laboratory 4. So, introduce myself, my name is David Teolongwe. My metric card is CE1I0146. So, this is my group member, Hazri Asa, Muhammad Ashif, and Novaika. So, our last lab is lab 6. Title is Interrupt Timer and PWM in ARM's Cortex-M3 Microcontroller LPC1768. So, next part I will pass it to my friend. So, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hasib bin Muhammad Anwar, which my metric number is DE180113. So, straight to the point, I will show the experiment of lab activity 6.1 and where we are needed to build the program and run the debug session. And I had built the program. Then we are needed to debug the session, start the session, and wait for a while until this layout is appeared. Where this is the logic analyzer that we are needed to open, and also we need to open the GPIO layout where we can get it by clicking on the referrals and GPIO interrupt of port 0 and also port 2, because in the program we had programmed the coding for GPIO 2 and also GPIO 0. So where we are needed to change the state of P0.0 and observe the output at P2.0 and P2.1 and the signals on the logic analyzer. So where we are needed to change the state at the P00 here and look at the state here of GPIO2. And also run the simulation and we can get the P2.0 and P2.1 is like this. So this is the result for P2.0 and P2.1 and the signals on the logic analyzer. And then we are needed to remove the clear the interrupt code in the ISR, reboot and debug the program, observe the result. So close it first and stop the debug session first. Stop it. Stop. And remove the clear the interrupt code first. Here. And then will and start it again. Observe the result. On the simulation and close the port 2. Observe the result. So this is the result. So now I in 6.2. Assalamualaikum warahmatullahi. Okay, now I'm in the 6.2 activity where we are needed to boot the program and run the debug session. And I have debugged the session, and also we need to run the program and observe the output in GPIO and logic analyzer window. Run the program, we run it, and observe the GPIO interrupt, also the logic analyzer window. And we can see the logic analyzer window. So this is the simple program to demonstrate the application of hardware timer for lab activity 6.2. I think that's all from me. Thank you.
Assalamualaikum and hi. My name is Nurfaikam Muhammad Yassin. Metric number DE18016. I gonna do for my part, which is lab assignment 2, which is to modify the program in listing 3.2 to use timer 3 instead of timer 0, and create a timing solution of 1 microsecond, and in the code flash the every 100 microsecond. So this is the coding that have in the report. So here timer 0 that I have to change to timer 3. So this is the coding that I have done, change it, and I try to beat, and we can see that there's 0 error and 0 warning. And after that we debug, and after that when we run the program, click on the view and click on the analysis windows and click on logic analyzer. From here we set up the logic analyzer program for a new insert. So here we rename it as a port 1 for 8 bits. So from here, display we type bits and color randomly choose. So close the program, and then after we done that, run the program here, and we can see the program is running and the logic is come out, and zoom in for the logic and stop the program, and then we can see the flash from the input to output. I mean when it's 1 here, and when it's go down is 0. So we want to see from here to here there are flash at the 99.36 microsecond, which is exactly nearest to the 100 microsecond. So this is my part. I will pass to the next presenter. Thank you.
Hi, my name is David Nyolongwe. So continue my part, which is lab assignment 6.1, where we need to modify the program such that interrupt is now P2.3 and this trigger at rising edge of P2.3. So this is a C programming code that I make. So this the coding change is here. So enable failing interrupt as P port 2.3. So it's here also, and the result is after we start build and no error and start debug and run and go to the logic analysis, and we find this result where the input interrupt 2.3 are tick. So in this case of the question is pressing as interrupt, and when P 2.3 is tick, meaning it's pressing where we create a racing S, then the output P2 with toggle. So based on this diagram, where this explanation is explain about this diagram. This is P2.3. So continue, my part is lab assignment 6.3. 6.3 is about create PWM signal with different duty cycle on PWM 1.1, PWM 1.2, and PWM 1.3. And PWM 1.1 equal to 20% duty cycle, and 1.2 equal to 50 duty cycle, and 1.3 equal to 80 duty cycle. So observe the output on the logic analysis. So this is our C programming code, where the change is we add this coding where need to set this to 10 millisecond and set to 20, 50, 80 duty cycle at this spot. And the result is where after we run, we build a target, start debug and run, and we go to the logic analysis and set to the P 1.1, 1.2.3 and see the result. So this is 20%, 50%, 80%. So that's all for my part. Thank you very much.
Assalamualaikum, I'm Yancy Azhar CPS Miral, metric number DE180128, and I represent group 2. So for the lab assignment 6.4, create a PWM signal. To vary the PWM duty cycle, where 0 volt we produce 0% duty cycle and 3 volt we produce 100% duty cycle. So this is the coding for the lab assignment 6.4. And this is the result that I get for the lab assignment 6.4.